We're going to look at the MEDACS model 2113 signal conditioner. MEDACS is a family of DIN rail modules. They all accept common instrument signals, and there's a choice of output options including 0 or 4 to 20 milliamp retransmission signal and trip relays. This particular model, 2113, is a single channel unit with a current retransmit output and 2 relays for alarm. The display keypad allows for menu programming. In the run mode, the process variable is displayed. I've programmed this unit to accept a PT100 input signal, and I can simulate temperature input signals with a decade box. So if I increase the reading, the maximum I got to there was 100.9, and if I go down, I'm going to a minimum 27.8, and then back up again to around about 58.9 degrees C. On the unit, in the run mode, I can press the green key and that will show me the peak value we got up to, which is 101, and the valley, or the low that we got up to, got down to rather, which is 27.8. Programming of the unit is done in the main menu by pressing, to enter this, press the blue and the green and then the red. Here we have 4 sub-menus: input programming, output 1, output 2 and a system. So let's go to the input sub-menu. This is where we can program the unit for whichever input signal we have. So green shows me the type, RTD. Now we've got a choice of other inputs, thermocouples, current voltage and so on, but we want RTD input, green and blue to accept. Linear, yeah, there's a choice of different types of PT100s, PT100, Japanese version of PT100s. We'll stay with the standard European PT100. Units, degrees centigrade or degrees F. We'll have degrees centigrade. Decimal point. Here there's 1 decimal point. We can change the position of that decimal point. Burn. This is the action of the output on sensor burnout. High or low. I've chosen high. Filter. Digital filter. We can set the filter time if required. And then back to type. To escape from a menu at any time, press the red and green keys. That brings us back to the normal operating mode again. Let's go back into the menu again to set the outputs. Blue and green, red, input, we've just done that. Now output 1, type, it's a retransmit signal. Span. Here's where we can set the span of it. 4 to 20 milliamps, 0 to 20, 0 to 10 volts. I want 4 to 20 milliamps. Low, retransmit low value. I've got this set at 0. So my 4 milliamps will correspond to 0.0 degrees. High. I've got this here. Here's where we can change the value. Here I go up to 300, 400, 500 and so on. I want the output, the range high, to be 100. So my 20 milliamps will correspond to 100 degrees C. That's it, now I'm back to type. So I've set output 1. Let's escape. Output 2. Output 2 is for the alarms. So let's enter this menu. Set alarm A. I've set this for to be an alarm at 85 degrees C. Again, to change this I can just use this key here to change the value, but I want it 85 degrees C and I want it to be a high alarm. I could have it as a deviation, various other alarms, low alarm. I want high, so my output 1 is going to be a high alarm. Hysteresis, this is where I can put a hysteresis on that alarm. Delay, I can put a delay in here in seconds. So after having set up output 1, I do the same now for output 2, which is B. Output alarm output 1 is A, alarm output 2 is B, and I've set this for 20 degrees. And the action of it as a low alarm. Now I'm coming out of that menu. Output 2, and I'll come back into normal operating mode. So basically what I've done is I've set up the retransmit output to be 4 to 20 milliamps, corresponding to a range of 0 to 100 degrees C, a high alarm to activate at 85 degrees C, and a low alarm to activate at 20 degrees C. So I've set up the MEDACS for a PT100 input signal, a retransmit output of 4 to 20 milliamps corresponding to 0 to 100 degrees C, a high alarm at 85 degrees C, and a low alarm at 20 degrees C. At the moment the MEDACS is showing a reading of 26.5, so I'll use the decade box to bring it up, and what I'll do first of all is check the alarm. This is shown on the meter here. That's set at 85 degrees C, so let's bring this up and go past 85. .6, 84.9, 85, and you can see the meter has changed over. The relay has changed over. So let's go the other way. Let's go below 20 to bring on the low relay. Okay, so if I bring this down gradually, there, it's changed over. From 21.6 down below the 20, and the meter's changed over. Go back up past 20 again, and the relay's changed over into its normal condition again. Now let's have a look at the retransmit output. 4 to 20 milliamps corresponding to 0 to 100 degrees C. So if I set 100 ohms on the decade box for 0 degrees C, I'd expect to get 4 milliamps on the multimeter. Which we get. If we now go to 100 degrees C, we should get 20 milliamps. And if we can get 50 degrees C, halfway, we'd expect to get 12 milliamps on the multimeter. $12 milliamps.